In this lesson, we are going to be simplifying radical expressions. So let's say we had the square root of 81 x to the fourth y to the sixth. So from the last lesson, we know that we can break that apart to square root of 81, square root of x to the fourth, and square root of y to the sixth. Square root of 81 is 9. Square root of x to the fourth, meaning what times itself would give me x to the fourth, would be x squared. And what times itself would give me y to the sixth, because we're squaring that, so y to the sixth, which would be y to the third. Also, you can think of, since it's squaring, we just take half of what the exponent is. So half of 6 is 3, half of 4 is 2, so that's our answer then right there. Another example, let's say we had the cubed root of negative 27 n to the third p to the ninth. So that means we can still, once again, separate those. So oops, and that should be cubed, and that should be cubed, and that should be cubed. So we're taking the cubed root of each one of them, meaning what times itself will give us each one of those. So what times itself would give us negative 27? Well, that would be negative 3. And once again, we can just divide the index, which is our 3, that's our index, and by our power, 3, so 3 divided by 3 is 1, so we just have into the first power. And then the next one, we take 9 divided by 3, so we'd have p to the third, so that would be our answer right there. And our last one we'll do with the fourth root. So we have 16 x to the fourth, y to the eighth. And again, we can separate each one of those. So that's to the fourth root, that's to the fourth root, and that's to the fourth root. So what times itself would be, what times itself 4 times would give me 16. So something times something times something times something 4 times would give me 16, because that's the fourth root. Well, that answer is 2. And again, so here we take our index and our power, divide the 2, and 4 divided by 4 is 1, so it'd be x to the first power, or just x, and 8 divided by 4 is 2, so it'd be y to the second power. And there would be our answer then. Alright, our first problem will be square root of 25 n to the third. So we're taking the square root of that, and once again we can separate each one of them. But you can see that with n to the third, we can't just divide that evenly by 2, because it won't come out even. Like we did in the past, on the previous page, it came out even. But the square root of 25 is 5. And here, the square root of n to the third can be broke up to n squared and square root of n. So that's what the square root of n to the third can be broke up into. Well, right here, the square root of something squared is just that number. So that square root of a number squared is just that number, and then we would have that along with it, so then that would be our answer. So let's say I had square root of 54 x to the fourth, y to the fifth, and z to the seventh. Well, we can separate each one of them. Square root of 54, square root of x to the fourth, square root of y to the fifth, and square root of z to the seventh. So we're looking for a square root. So let's see if the 54 has a perfect square in it. That means something times itself would be a perfect square, since we're square rooting. Now if it's cubed root or fourth root or fifth root or anything like, we wouldn't be able to do that. We'd have to think about something that would be 3 times or 4 times or 5 times. But here we can look for something that's a perfect square root. So square root of 9 times square root of 6. So we'd have that, and here we can take square root of x to the fourth. So once again, just divide it in half. So we have x squared. Here, this would be square root of y to the fourth, y to the first, or square root of y. So, square root of y to the fourth, divide the 2, so we have y to the half, y squared, and then we have to bring along the y. And for z to the seventh, that's square root of y to the sixth, square root of y. So square root of y to the sixth, just divide it in half. So 6 divided by 2 is 3, so we'd have y to the third and square root of y. So now to simplify it, or put all this stuff together, square root of 9 is 3, so we're done with that. We can take the square root, or x squared right there, bring that down, so we're done with that. Right here, y squared and y to the third, or excuse me, that's supposed to be z, isn't it? Yeah, sorry about that, that should be z. That should be z, I meant to put those in there. I don't know why I put y, but that should be z. So we have y squared, and then we'd also have that there, so we get rid of that. And let's see, we have z to the third, so get rid of that one. And now we have, what we have left here is this one, and square root of z. So we can put all those back under the square root. So we have square root of 6y z. And that would be our answer. Sorry about that. That's kind of messy. Since I messed up there with the z, I thought I wrote y and it should have been z. Alright, so our next one is cubed root of 54 n to the third p to the seventh. And I've already broke each one of them up separately to save some time here. So now we're looking for something that we can't look for a perfect square because we're not squaring, we're cubing it. So we're looking for something that would be a perfect cubed. So that would be the cubed root of 27 and the cubed root of 2. And you just got to think about those. It just takes a while to think about what times itself would give me, or 3 times would give me that. So it's not real easy like the square root. And once again, the cubed root of something cubed just cancels out. So we're left with n. And this would be cubed root of p to the sixth and cubed root of p. So we can take half of that, 6 divided by 3. So we'd have p to the second, and then we'd have the cubed root of p left. So down here then we'd have the cubed root of 27 is 3. The cubed root of 2, can't do anything with that, so we're just going to leave that alone right now. We got the n, got the p squared, and everything else left. The cubed root of 2, cubed root of p, we're going to put those back underneath each other, and need the square root, or the cubed root, and then there will be our answer there. Alright, so we have the square root of 10x squared y times square root of 40x y cubed. So we could put the 2 square roots together, this one and this, so that'd be the square root of 400. And that means square root of 400 is 20, so that's why I did that. I put those together. So we're done with those now. And we have the square root of x squared right here. Well, those cancel out. The square root and the x squared cancels out. So I'm left with x. And then I have the square root of y to the third would be square root of y squared and square root of y. Well, the square root of y squared cancels out, so then I'm left with just y. So I have that done, and then I can put these two together. And that would give me square root times the square root of y is y, and y times y is another y. And then I have square root of x. So my final answer would be 20xy squared, square root of x. Alright, so now to go on. If we have, if you remember from algebra, 2x plus 3x equals 5x. Same way with the square roots or anything roots, radicals, that these have to be the exact same in each one of them. So these represent like the variable x up in the above in the one I just did there. So 2 square root of 3 plus 3 square root of 3 is 5 square root of 3. You don't add the square roots, Those act like variables, so you just bring it along, just add the coefficients. Alright, here in this one we have this cubed root of 40 minus 2 cubed root of 5. So since these are not exactly like, we cannot put those together, so we have to break it apart a little bit so we can get those like variables in there, the like radicals. So I found out that cubed root of 8 and cubed root of 5 is 40, so this would be 2 cubed root of 5, and that's good because now, that should just be minus, sorry about that, 2 cubed root of 5, and I can now see that these are exactly the same, and 2 cubed root of 5 minus 2 cubed root of 5 is 0. Alright, so we have square root of n times square root of m times square root of nm. So we're going to distribute that, so square root of n times square root of m plus square root of n times square root of nm. So this is going to be, let's see, we can separate this part right here to square root of n square root of m. So now we have square root of n times square root of m plus square root of n. Well, if we put these two together, square root of n times square root of n is n. So now I have the square root of n square root of m plus n square root of m. And we cannot put those together because it's like, I know you can see that you have this and this, but you can add these together because you don't know what this is and you don't know what this is. So then my final answer would be square root of nm, because I'm going to put those back underneath 1, plus n square root of m. Okay, from past lessons, you know that n plus 2 times n minus 2 is equal to n squared plus 2n minus 2n minus 4, and my final answer is n squared minus 4. It's a difference of squares. So that's just a little review. So let's try one with square roots in it. So once again, I'm going to FOIL, just like I just got done doing with the n plus 2, n minus 2, just FOILed it. So if I FOIL these, do first, outer, inner, last, I'd have 5 times 5, which is 25. That times that would be minus 5 square root of 3. That times that would be plus 5 square root of 3. And that times that, which means square root of 3 times square root of 3 is just 3. So then, these cancel out because I have a plus and a minus, just like I did here. 2n minus 2n. I have a negative and a positive, so those cancel out. So I have 25 plus 3 then, which would be, that should be minus there, because I have a negative times a positive. So I have 25 minus 3, which would be 22 then for my answer. Alright, next one is square root of n to the 6th over m to the 5th. Each one of those can be separated like I just did right there. So the numerator and the denominator can be separated. So to simplify that, square root of n to the 6th is n to the 3rd, because remember, you just take half of your square root. And on the bottom, you take half of it, so take one less than that, would be 4. Half of 4 is 2, and then you got the 1 left over. Now, to get rid of this, one rule is you cannot have a square root in the denominator. So in order to get rid of that, we'd square root, take it times square root of itself. So since we got to get rid of this one here, we have to take it times square root of n times square root of n. So then I'd have n cubed square root of n over m squared, and n squared, the square root of n times square root of n is n. So that would be my answer there then. And once again, I made a mistake. I'm trying to hurry so I don't go over 15 minutes. That's why. So everything that I put in, now I have red, change yours so it is m's instead of n's. Sorry about that. Like I said, I'm trying to hurry so it doesn't go over 15 minutes. Alright, I have 6 over 2 minus square root of 7. You gotta get rid of the square root, so I'm going to take it times its opposite, which is called the conjugate. So I'm going to take it times 2 plus square root of 7 on the top and bottom. In the bottom, you can see in the green, then I FOILed that, and I got negative 3 as my final answer. And then if I distribute the 6 to everything in here, I'd have 12 plus 6 square root of 7. And I can separate each one, because now I have negative 3 underneath both of them, so that'd be negative 4 plus negative 2 square root of 7, which would be negative 4 minus 2 square root of 7. And that's a lesson, and sorry I went so fast, so you might have to go back over them because I wanted to hurry to make it less than 15 minutes, but I'm not going to hit that. So hope this helps.